Okay, so let me take that answer. Iman? Iman here?
Yes.
Yichin? Yichin? Yichin's here.
Yes.
Okay, thank you. Porostia? Porostia? Oh, yeah. Okay, Remy? Oh, yeah. Izzar?
Yes.
Okay, thanks. Haris?
Yes.
Haris, okay, good. Chiki?
Yes.
Praveen?
Yes.
Marwan?
Yes.
Shinho? Shinho? Shinho, not here. John?
Yes.
Okay. Gavin?
Yes.
Okay. Two of you, Let's, okay, so let's continue this lesson. Okay. Let's shut down the mic. Is that clear recording? All of you shut down the microphone. When you want to talk, you can on it if you have any questions. Okay, so hope you can see the PowerPoint. Everyone can see the PowerPoint,
Yes.
Okay, good. Okay, so far we are still under forces. So we are towards the end. We try to finish it today. Okay, so we learn about the type of forces. After the type of forces, we learn about what is meant by equilibrium. Then we talk about center of gravity. After center of gravity, we move on to moment. Okay, moment. Then we talk about couple. Okay, a couple of moment of a talk. Okay, so what is a couple means? Equal, parallel, never coincide. Never coincide, and another two features lah. So couple only gives a turning effect. Okay, so now you see on this slide now, you are seeing object again. It's in equilibrium. The beam is in equilibrium. Okay, the beam is in equilibrium. Neglect the mass of the beam. Okay, so find the tension of the beam. How much is the T applied in this system? How much is the T? Okay, how much is the T? There's the part A and part B. What is the force between the beam and the wall? What is the force between beam and the wall? So beam and the wall, there is a force exert here. There is a force here. Okay, they're asking how much is this force? Hey class, just for your information, pivot, there will be a force at pivot always. Okay, if this is pivoted here, the pivot will have a force. That force is unknown. Normally they won't ask that force. Sometimes they do ask. Okay, so remember at pivot there is a force, unknown force acting on it. Okay, first give a try. You should get 824 and 353. First, find the tension in the cable T. How do you find the tension here? So do you go for moment or do you go for net force? Okay, which one do you, sorry, yeah. So how have you done this? So first, if you go for resultant force, the force up equals to force down. Okay, force up equals to force down. How many force up acting here? The F and T, two unknown. Then force down is the weight of the object under 20 kilogram. Okay, So you can make a lot of equation. The first equation you can make is from the net force. So F plus T should be equal to the 1200 9.81. Okay, this is one equation we can obtain through what? Through net force. Force up equals to force down. But this equation got how many unknown? Two unknown, F and T. We want to find the T, so I think not enough to find T because we don't know the F. Okay, so always one equation can be obtained from the net force, and you can obtain a lot of equation from the moment. Okay, moment. So I think in this case you better use moment to find the T. Okay, to find the T you use moment. To use moment you must identify the pivot. So in this case, where's your pivot? They never mention there is a pivot here, but you can, if they never mention where's the pivot, you can choose any point as the pivot. Okay, now which point you like to take moment about? Which point you want to like to take as a pivot?
The wall.
The wall. So you take the pivot as the wall. Okay, why you take pivot as the wall and not other points?
Because
What is the advantage of taking pivot at the wall instead pivot of the mass as the pivot?
there is no force on that point.
Yeah, okay. So the more important thing is we are prefer pivot on the wall because we don't want the F to appear. We don't want the F to appear in the equation.
Okay.
Okay, that's why we take the pivot at the wall, because if you take pivot at the wall, the F is acting at the pivot, so F won't appear in the equation because it doesn't give any moment at the pivot. That's the main reason, because our focus is finding the T. So can you calculate how's the moment looks like if you take about pivot P? So check all the forces acting. First, the weight giving what type of moment? Weight giving clockwise moment. Okay, clockwise moment. And T acting up, giving what type of moment?
Anti-clockwise.
Give an anti-clockwise moment. Give an anti-clockwise moment. Okay. So at the pivot, the moment caused by T must be equals to moment caused by the weight. So how's the equation going to be? So T times what? T times perpendicular distance, how much? Perpendicular distance is 10 meter. Yeah, good. 10 should be equals to moment caused by the weight 120 times 9.81. You see? Okay, you see? So this is another equation. We get it by taking moment about P. Okay, moment about P. So here you see the benefit of taking moment about P. The F doesn't appear in the equation. So easy to calculate the T, only one unknown. So you can find the T already. Okay, so you can find the T. Okay, after you find the T, so how much the T will be? 120 times 9.81 divided by 10. You will get your answer. Okay, so just learn the technique first. So after you find the T, question B, what is the force between the beam and the wall? So they're asking F. So how do you find the F? Use the first equation. Net force is enough. Net force can find the F. F plus T is 120 times 9.81. Now T, just substitute whatever T you got here, you can substitute here. You can find the F. Okay. So yeah, this is how it works. So whenever asking forces in an equilibrium body, if there is a two forces, you need two equations. Okay. Net force can give you one equation, and moment can give you multiple equation, because different pivot give a different equation. Okay, which point you choose as a pivot? Choose the point where the force is unknown. The force is the force you don't want to appear in the equation. You then use that point as a pivot. Okay. Okay, so this is the working just now. So the torque must be 0, or the resultant moment must be 0 about the pivot. So we take that axis as the pivot. So TL minus mgx, right? T times L, L is 10 meter, minus mg times x, x is 7 meter, must be 0. Okay, clockwise moment, TL is what? Counterclockwise moment must be equals to the clockwise moment. So equals to 0. So you get one equation. So you can find the T. You get 824. Okay, B. So the force is up. As I say, at the pivot, there is always a force acting. So by using net moment, the force vertically must be 0. So force up equals to force down. So F plus T minus mg equals to 0. So you get another equation. T you already know from part A, so you can find the F. Okay, you find the F. Okay, the F line you should get 353 Newton.
Wait, the tension is 824.
824.
Can we see the calculation? Oh,
Do you calculate? Do you get 84?
wait.
You got a different answer.
Because 120, right? Times 9.
Okay, hold on.
Divided
This is the 120 times 9.8. 120. 120 times 9.81 divided by 10. What do you got?
100.
Oh, sorry. Mistake. Here must be
One.
multiplied by the length. The length is what? 7 meter. Right? Because moment,
Wait.
right?
Oh yeah.
So now I think you should get epsilon. 120 times 9.81 times 7 divided by 10. Get the T. So I didn't put the 7. Okay. Now you got the answer? 824?
Wait.
120 times 9.81 times 7 divided by 10.
Yes.
824. Okay. Good. So the important is the technique. So we done this. Okay, so then you substitute the T, you get the F. Okay. Okay, now alternative solution. You can use other point also as to find the pivot. You can use this axis also as a pivot. Okay, but if you use this axis as a pivot, which force won't appear in the equation? Which force won't appear in the equation? The tension won't appear in the equation because you tick under T as the pivot. Okay, so you take this as point as the pivot. How's the equation going to look like? Moment. The F create what type of moment about this pivot? F create what? Clockwise moment. The weight create anti-clockwise moment. So the moment caused by F must be same as moment caused by M about this axis. So you should get what? Get this equation, right? F times L, F times the entire L, okay, is equals to minus put it one side, mg times L minus x. Okay, L here is the 10 meter, x should be, so L minus x, x should be the 7 meter, so it should be 3 meter. So you get 353. You will get the F straight away. It is an alternative method. So yeah. Okay. 1 minute for you. Now real time, real life application. So your arm, you have biceps, you have ulna. So you are holding let's say an object, a ball here, which is 50 Newton of weight. Okay. So our body is also mechanical. So the pivot is at this joining of the bone. Okay. So you are holding an object. So the muscle is the one going to pull up so that your arm is, your ulna is like horizontal. Okay, horizontal. So this is totally the equilibrium system. Okay. So tell me now, find the F, find the tension in the muscle. F is the ulna is in equilibrium. Okay, find the tension in the muscle, the bicep muscle. If it's the ulna is in equilibrium. Okay, Now, how do you find this? First thing, always identify all the forces acting on the system first. What are the forces acting on this system? The ulna. Ulna, I just put it like a rod. Pivot here. Okay. What is the force acting? The muscle pull the ulna up. Tension. F. This is the force we are looking for. Then the ball which is sitting here, is pushing it down with how much of force? 50 Newton. Yes, this is a simplified system. Okay. So pivot, remember there is a force acting on the pivot. Okay, should act down in this case, but that force is unknown. They never ask for that force. So to calculate your F, you take moment about which point? About the pivot. You better take moment about the pivot. So if you take moment about the pivot, moment caused by F times this distance should be equals to 50 times this distance, right? Moment caused by F is which is a clockwise, anti-clockwise, go around the pivot. This is a counterclockwise moment. 50 gives a clockwise moment. Moment caused by F must be same as moment caused by 50. So that's the solution. So this is the system as I told you. You have the force at a pivot R, it's unknown. Okay, we should act downwards to balance it, but we don't know the R. So, but the question looking for F, you better take moment about R, about the pivot. So we don't want the R to appear. Okay, so taking moment about O, the counterclockwise, anti-clockwise moment must be same as clockwise moment. So F times X, F times this X. Okay, of course this is the X. It's the X. Okay, from the moment times W times L. L is 0.350. So you should get that 583 Newton. Okay, so be careful which one you want to take as a, you want to calculate the moment. If there is a pivot provided, better go for pivot. Why? Because there is an unknown force acting on the pivot. Okay, so we don't want to ignore that force. We want to avoid that force to appear in the equation. So that's why we take moment about the pivot. Okay, so if you never take moment about the pivot, you take moment about, let's say 50 here. You're taking moment about at this point, let's say this as a pivoted point. You want to take moment about this point. So what is the problem we're going to face? F times this distance should be equals to R times 0.350. So now we start, because we have two unknown now. We don't know the R, we don't know the F. So we can't afford to find the F because we don't know the R, because R appears. That's why to kill the R, you better take moment about the pivot. So R won't appear. Clear? No problem so far. So pivot given, take moment about the pivot. Pivot, there is an unknown force acting. Okay, that's the that repeatedly I'm telling this many times. Okay. So yeah, what is the R and the reaction force by the numerous? So you take moment about center. This is the second question. Now they're asking what is the force at the R. So now they're asking force at the R, the force at the pivot. So if they're asking force at the pivot, now you can take any point as the pivot. According to here, the working, you take moment about the F here. So moment caused by the R must be same as moment caused by the 50. Okay, so we are taking moment about here. So moment caused by the R should be equals to moment caused by the 50. So yeah. So R times X, R times, which is your X? This distance, this is your X, perpendicular distance, should be equals to W times L minus X, 0.30, 0.03. That's this value, 0.03. This value, so you can get the R. Okay. Yeah. Any questions? Can Okay. So let's continue. Okay. Another system. Okay. Now I leave it to you. 1 minute. Consider the 400 kilogram uniform beam shown. Determine TR. Okay. Determine the TR. How much is the TR value? Okay. So which point you take as a moment now? Come on. Anyone tell me which point is a logical way of doing? You want to find TR. You want to find TR. This system got how many forces acting? TR acting up, TL acting up, weight acting down. Okay. You are looking for TR. So which point you take it as a moment to calculate the moment? TL?
Yeah.
TL, yes. The smart way is you must take pivot at take moment about TL. Take this, consider this as the pivoted point. Take moment about TL. Because of what? We don't want TL to appear. So you can find the TR. So moment caused by TR, which is counterclockwise moment about this pivot, and M is clockwise moment. You can get the answer. Okay. So yes, torque is 0. So we're taking moment at that point as the pivot because we don't want the TL to appear. So yes, this is the working, right? Mg times x. How much is the x will be? X will be how much? X will be this distance, X will be this distance. How much the x in this case?
2.
2 meter. So x is 2 meter. You should know x is 2 meter. And TR times L. L, how much take the L? TR times, which is L? TR acting here. So L is this one, 7. So this is your L. 7 meter. So L is 7. Okay, then you can work out your TR. You can find the TR. So in this case, you should get 1120 Newton. Okay, so this is how you have to analyze the system. Okay, so you must be smart enough to take which point as the pivot. If the force, there are two unknown, and one of the unknown, they never ask for that unknown, you better take moment about that point. We don't want that force to appear. Okay. So now the system changed slightly. Okay. How do you do this? This is first time the force is diagonal. Okay. So diagonal. A beam of weight 200 Newton, length 1 meters, inch at point P. Oh, so this is the pivot here. They say inch at point P. A string of 1.5 meter is attached from the end of the beam of the wall. Or this string is 1.5 meter attached to the wall. And okay, the beam of weight 200 Newton. So the weight is 200 Newton. It's weight 200 Newton. And the length is 1 meter. So beam length is 1 meter. Okay. Okay, now what do you want? Calculate the tension on the string. What is the tension on the string? The tension is acting up or down?
It's up.
Is up. The tension acting up because we are focusing to this point. This body, focusing to this body, tension is acting up. Okay, pulling it up. Okay, so we are asking for this tension. Okay. So first, the angle made is a theta. Theta, we don't know. Theta they give.
Oh.
Okay, theta. So attach from the end, calculate the tension on the string. And they ask what is the force on the hinge. How do you find? Taking moment about P, taking moment about P, total moment must be 0. Total moment must be 0. So 1.51 meter. Okay, now the problem is theta. Can you find theta?
Um,
How much is theta? Theta is needed.
Cos.
Can you calculate theta?
Yes.
it's,
Theta, the
it's
length is 1 meter. The string is 1.5 meters. So use tangent theta, right? Tangent.
Cos.
Cos, yeah. Cos theta 1 divided by 1.5 gives you the theta. So theta, you know, we can find the theta. So taking moment about 0. So 200 times 0.5, this distance, because we are taking moment about P, is equals to T sine theta. Yes, we have to be T sine theta. We have to resolve up. So we want to get the vertical component of the T, vertical component of the T, Ty. Okay. So you open the theta. So T sine theta times 1. Okay. So this is the equation you should get. Okay, by taking moment about what? About P. So something new here is the tension have to resolve vertically, because it's diagonal. Okay, then so you can find the T. Okay, someone get me the answer. How much the sine theta? Sine theta we cannot find. Yeah, opposite over adjacent. So theta we know this is 1 meter. This is 1.5 meter. Then cos theta we know. Cos theta how much? Because the triangle. There is a triangle. This is 1 meter. This is 1.5 meter. What is the theta will be?
48.19.
So theta you get 48.19. 2, 48.2 degrees. 1 divided by 1.5, right? You did. Okay. So the theta you know is 48.2. So substitute theta is 48.2. So then you can find the tension. Anyone? What's the tension you got? Okay, for me, 200 times 0.5. So it's 100. 100 over sine 48. 100 over sine 48.2. What do you get?
134.
134. 134. Good. 134. Okay, so it's 134 Newton. The answer. Okay, so taking moment about P, you can avoid the F appearance. So this is the equation you tried. Sine theta, you have to use cos theta to find the theta first, then substitute, you can find the tension. Okay. Okay, class. Please off the mic, some sort of a background noise, I think. Okay. So when you talk, you just on it. Okay, so now next question. The force acting on the hinge. So they're asking F. How much is F now? It also act like a certain angle from horizontal beta. Beta, I don't know how to find beta, but because it's in equilibrium, so two methods. Because it's in equilibrium, the moment vertically, the net force horizontally and net force vertically must be 0 because it's in equilibrium. Okay, so the px is t cos theta. Px is what? T cos theta, the horizontal component of the tension lah. The tension is acting here. What is the force acting this way? Is T cos theta. T cos theta. What is the force acting up? Is T sin theta. Okay. Resolve this force also. If this is F means, what is the force acting horizontally here? F cos beta. F cos beta. What is the force acting vertically up? F sin beta, right? F sin beta. Okay. Why we break this all to components? We want to say vertically up, force must be balanced. So force up must be equals to force down. And horizontally, force to the right must be equals to force to the left. That's why I break them into component. So Px is T cos theta. So Py plus T sin theta, Py plus T sin theta, Py plus T sin theta, T cos theta. Okay, T cos theta. Px is T cos theta. So Py is T sin theta equals to W. Okay. So in this case, so try to understand what is Px and Py lah. Px, Py is this components lah. This is your Py. Okay, this is your Px. This is your Px. The Px, Py is the component of this F lah. So Px should be T cos theta because Px should be same as T cos theta. This is your Px. The Px is same as T cos theta. Okay, because these are the two horizontal forces. Px acting to the right, T cos theta acting to the left. They must be same. Okay, Px is T cos theta. But we know Px is F cos beta lah, if you put it in beta form. Okay, Py is what? Py plus T sin theta up should be equals to the force down, which is the W. Right? Py is the vertical component of this force, the F, plus T sin theta, the two force acting up, should be equals to the W down. So that's why Py. So Px and Py lah. Okay. So P is actually what? P is the actual force. I put here F, but the working they put it as P. The F and P is same. So if you can work out Px and Py from these two equations, you can find the P already. You can find the P answer. Okay. So then after you find the P answer, you can work out the angle beta also. You can find the angle beta also. Because this is P, this is your Px, this is your Py. So this is your beta. So you can work out the beta. Once you know Py, Px, and also P, you can find the beta. It's trigo. So beta can be found also. Okay. So this question is slightly different because it's diagonal. Okay, it's diagonal. So vertical force, if it's diagonal, net force can give you two equations. Vertically, the force is balanced. Horizontally, the force is balanced. Okay. So yes, this is how you solve the problems lah. Any question from this diagram? No problem, Okay. So this is all what I told you. Okay, now come to the ladder. Okay, rough wall, rough floor. Okay. So what are the forces acting on this ladder? The weight acting down. The normal force is acting to the left because the ladder pushes the wall going to push it back. Normal force always 90 degrees from the surface. That's why normal force. Then here also the ladder pressing down, so the normal force acting up. So normal force acting in two places. Friction acting up here and friction acting to the right here. So these are the 5 forces acting on this body. Okay. Okay, now you see these are 5 forces. Do you understand what is done just now? The 2 forces on top, the normal and the friction, is merged to form a resultant. The resultant it should be the blue color. Okay, in between them, the resultant force. Okay, and the bottom also, this normal and the friction, we can merge. So that is the resultant of that two forces. Okay, why we do this? Because in A levels, to draw vector diagram, you normally go for three forces, just the three forces. Okay, so you see 5 forces become 3 forces only. So the force at the bottom is moved diagonally up here. The force on the top here move diagonally to this direction. So weight acting down. If this is in equilibrium, if you prolong the line of action of the force, the 3 forces must coincide at one point. It should coincide in one point. If it coincides in one point, we say this ladder is in equilibrium. Okay. Yes. So this is how you find out. So the simplification line, the two forces can be merged to become one.
I have a question.
Yeah.
How does the angle of the two resultant forces 90 degrees?
The two resultant forces, the angle between.
Yeah, is it 90 degrees?
Not necessarily. 90 degrees means between what?
Degrees. How do we find the angle? Like, for example, the one with the rough wall, we can know it's 90 degrees towards the plane, right?
Yeah.
Yeah, but what about the one with the floor? The floor one.
Oh, this angle.
Yes.
You are asking this angle, is it?
Yes. Yes.
Okay. So first this angle first. This angle. These two forces. Okay, hold on. Okay. First, to find this resultant. Okay. Let's say the friction. Let's say 8 Newton. Okay. Let's say normal is 10 Newton. Okay. Normal is 10 Newton. So what is the resultant will be? Resultant will be 8 squared, 10 squared. So you can work out this angle, right? This is 8, this is 10. So you can find this angle, correct?
Yes.
You can find, let's say you got 40 degrees, let's say. Just put 40 degrees, 40 degrees. So you can use a protractor, measure 40 degrees. That's the resultant here, okay? Okay. This third one is very easy to find. The ladder is here. So now the force on top is like this, makes, let's say 40 degrees from vertical, and the weight acting straight down. Okay, weight acting straight down. Okay, this third force we know is acting somewhere this direction, but we don't know what angle to draw. It's very easy. What you do, if this ladder is in equilibrium, these three force 1, 2, and 3, they must meet at a single point. So 2, you prolong the 2, you prolong the 2, it's cutting where? It's cutting here, right?
Yes.
So this third force must pass through this point also. So you just draw a straight line. Just draw a straight line, so you can measure the angle if you want now. So they have to meet in a single point if it's in equilibrium. That's a fact to remember. Okay. It's how you find life. They ask you to draw. Okay. Okay. So now, the earlier case, the floor is rough, the wall is rough. So both has friction. Okay. Now you see, sometimes they put like this. Wall is smooth, floor is rough. What's the difference? A smooth wall means there is no friction. So in the smooth wall, there is only one force acting. What is that? Only the normal force acting. The rough floor, you have both. You have the normal force and the friction. The weight is acting down. Okay. So in this case, this is how the intercepting should happen. Okay. The normal force here and the weight intercept here. So this force must be tilted such a way that it passes through this point. So that's the equilibrium point. Okay. This is smooth wall. In exam, they will have rough, or rough and smooth wall. You have to be careful. Check the question. If smooth means friction is not there. Okay. Okay, so now one example. 1 minute for you. A uniform ladder of weight 500 Newton and the length of 1 meter is placed on a rough floor. Floor is rough, leaning against a smooth wall. Wall is smooth with an angle of 30 degrees to the vertical. Okay, calculate the magnitude of the forces acting on the floor and the wall, respectively. Calculate the magnitude of the forces acting on the floor and the wall, respectively. Calculate the magnitude of the forces acting on the floor and the wall, respectively. So they're asking the resultant force lah. They're asking the blue color, this one, the resulting force F and the normal force here. Because these are the force acting from the wall. These are the force acting from the floor. Floor has two force, the normal reaction and the friction, but they want to calculate the magnitude of the forces acting on the floor. I think they going for the resultant forces. So 1 meter length. Okay, so the ladder is 1 meter. Weight we know is 500 Newton. Okay, angle we know is 30 degrees, leaning to the vertical. Angle of 30 degrees to the vertical. Smooth wall. Okay, so 30 degrees. So 30 degrees on top here. Okay, so this is your simplification. So how do you solve this? Choose a point where the most unknown, okay, example is P. Yeah, take P first. If you take P as a pivot, R and F won't involve, but we can find the N already. We can find the N. If we take moment about P, how the equation looks like moment. So if you take moment about this P, these two forces won't appear in the moment equation. So W and normal force give the moment. What is the moment caused by W about this pivot? So W times, what is the perpendicular distance? Perpendicular distance, this is 1 meter, this is 1 meter, diagonally 1 meter. So horizontally should be how much? Should be 1 sine 30, right? This is 30 here. So you take the vertical component, so it should be 1 sine 30. So this be half of 1 sine 30. Okay, I think should be 0.25. Okay, so taking moment about this pivot P, the moment caused by W is 500 times 0.25 should be equals to moment caused by N. N is N times what is the perpendicular distance? N times what is the perpendicular distance? It's going to be the perpendicular distance, the vertical, which is 1 cos 30. Diagonally is 1 meter, so vertically should be 1 cos 30. Okay, so that's the equation. About P, about point P, the clockwise moment caused by W must be equals to anti-clockwise moment caused by N. So moment caused by W is what? 500 times I sine 30 divided by 2, because half of it. Totally is I sine 30. We just take half I sine 30 divided by 2. This is moment caused by weight. Should be equals to moment caused by the normal force. Normal force here. So normal force times I cos 30, vertical distance. So from here, how many unknowns you have? Only N. So we can work out the N. So we can find the N. Okay. So no problem. So we can find the N by taking moment about this point, because we don't want this R and F to appear. We want to find N. Then how do you find, okay, how do you find F and R? Okay, do you understand this too? They said F is equals to N. Where is F? F is which way? F is this way, to the right. F is to the right. Why they said F should be equals to N? Because what concept they use here to conclude that F equals to N? If the ladder is in equilibrium means
Left and right is the same.
the total horizontal force must be 0, right? Force to the right must be same as force to the left. For this ladder, what are the force to the right acting? F. What is the force to the left acting? Solely N. So F and N must be same. So that's why they said F is same as N. So whatever answer you get N, that's your F value. Okay, taking this total sum of force to the right must be same as force to the left. Or the total net moment and net force in X direction must be 0. So F equals to N. Okay, how they conclude the second one? R is equals to W. How they know that? Vertically, the force must be balanced, right? Force up, which is R, must be same as force down, which is W. There's only two force acting up and down. So R must be same as W. So therefore, R should be 500. Okay, so this is how you find the forces. Okay, so how do you visualize it? Okay, so you can use moment. Moment is very versatile. You choose a different point, you give an equation, but you must be smart. Which point to take as to calculate the moment? If the force there unknown and you don't want that force to appear in the equation, use that point as the pivot. Okay, so you can make lots of two equations from the net force. Vertically and horizontally, the force must be balanced, two equation, and you can make lots of equation by using moment. Okay, normally in these equilibrium questions, normally they have two unknowns. That means you need two equations. Two equations means one get it from the net force, another one you can get it from the moment normally. These are the answers. Okay. Okay. So I go to one pass here. I just skip this. Okay. So one pass here now. Okay. This is a tricky one. I think you are ready for it. I think I want to ask this. 16. Let me minimize it. Okay, question 16. 1 minute for you. Think carefully. Get me the answer. All of you. You can put it in WhatsApp. You must have a reason for your answers. Okay. So figured it out. Just send me the answer. Which list gives the three forces in increasing order of magnitude? Which do you think the lowest force? Which should be the highest force? With the reason. Okay, so get me the answer. Can send me. Anyone?
Wait.
Think about your net force. Think about your moment. The force up must be say equals to the force down. The moment must be the net moment must be 0 about any point. So use these two rule. Okay, I received the answers. So one of you say A, another one say C. So I got two answers, A or C. A and C is opposite to each other. Eh? Which list gives the three forces in increasing order, the smallest to the highest? Okay. So which is the highest force? The T is the highest force, for sure. So T should be the highest force. What is the reason T should be highest force? Anyone? Why T should be the highest force? With the reason? Anyone? You have a reason for it. Why T should be the highest force? Because that's the only force acting up. Right, that's the only force acting up.
No.
So force up should be equals to force down, right?
Okay.
So T is the only force acting up, the H and W acting down. So T is supposed to be the greatest lah, because he's the only force acting up and he's balancing the other two. So no doubt lah, T is the highest. Okay, so the reason why T is the highest, I can say that's the only force acting up. So T should be the highest. Okay, next. So because T is the highest, of course, the only answer with the T maximum highest is C. So of course the answer is C. Okay, but now let's think further. The C said W and H. H is the second largest, W is the lowest. If this question is not an objective, how do you know W is the lowest and H is the second highest? With the reason. Why H must be the second highest? Why H must be greater than W? How do you, with the reason? You're taking moment about which point? You can compare them.
Because H is a shorter distance than W.
Shorter what distance? Shorter perpendicular
Distance.
You are taking moment about which point, then you can compare them. You want to compare H and W, take moment about which point? Take moment about the T.
Yeah.
If you take moment about T, you can compare the H and W already, because T won't involve in the equation. So if you take moment about T, the H times perpendicular distance, this is your perpendicular distance. H times perpendicular distance must be same as W times, where's your perpendicular distance? This is your perpendicular distance. So here very clear, the perpendicular distance of H is small. The perpendicular distance of W is further. So that means shorter distance must lead to greater force, right? Because moment same. H times perpendicular distance of H is equals to W times perpendicular distance of W. But perpendicular distance of H is small, so the force H must be greater than the W. So if you really understand, to compare H and W, you must make sure T not involved. So how to make T not involved? Take moment about the T point. You can compare the H and W. Okay, so good. Those who got answer C should be C. Why T should be greater? That's the only force. Why H should be greater than W? Because H has a shorter perpendicular distance. When you take moment about T, that's the answer. Okay. Any questions from here? Clear, huh? Okay, so let's move on. Another one question. Okay, this one. 13. 1 minute for you. You try. Tell me the answer again. Sorry. Three forces act on the lever, arm, shown in the diagram. What is the magnitude of the resultant moment of these forces about point P. So what is the resultant moment about point P? This is a pivot. They want the moment about point P. So first, you identify what? Check the moment caused by these three forces. Which one is clockwise moment? Which one is anti-clockwise moment? You have to figure out that first. The moment your P is the pivot, 5 Newton give a clockwise moment or anti-clockwise moment. 5 Newton. Go around the pivot. So 5 Newton gives a anti-clockwise moment. 10 give what type of moment? Go around the pivot. 10 go around the pivot. 10 give a also anti-clockwise moment. 20 gives what moment? 20 gives go around the pivot. Go around the pivot. 20 gives clockwise moment. So 5 and 10 is anti-clockwise moment. 2 gives a clockwise moment. 20 gives a clockwise moment. Okay. So total clockwise moment minus total anti-clockwise moment, or total anti-clockwise moment minus clockwise moment. Anyway, will do. Okay. So what is the moment caused by 5 Newton? What is the perpendicular distance of 5 Newton from the pivot?
2.
2. Very good. So 5, you prolong the 5. This is your perpendicular distance. How much is that? It should be 2. This is 3. So here 3. Sorry, here total is 4. Here 2. So here should be 2. So moment caused by 5 Newton is 5 times 2. Moment caused by 10. What is the perpendicular distance of 10 above the pivot? Prolong the line 10. 10 is this line. This is the line of action of the 10. So where's the perpendicular distance to the pivot? This is your perpendicular distance of the pivot. Okay. How much? 2. The 10 also, the perpendicular distance is 2. Okay. So anyone give me the answer? A.
A. Yes.
Is it A?
Technically, it's negative 30, but it's
Negative 30. So all of you giving A. A.
clockwise 30.
Clockwise 30. 5 times 2, 10. 10 times 2, 30. 5 times 2, 10. 10 plus 30. 30 clockwise, anti-clockwise moment. And clockwise moment is 20 times 2, 20 times 3, sorry, 60. So finally, it's a clockwise moment, 30. So answer is A. Answer is A. Okay, good. So those who got A, correct. Okay. So take the perpendicular distance. Perpendicular distance. Okay. So let me ask you the final question. So we've done many about the moment already. Okay. We're going to move to the next part. But before we go to the next part, last question. Okay. Okay. The last question is this. I want you to do and give me the answer. There is a platform. Okay. The platform is about 4 meters in length. There is a 2 cable tied to the wall, to the upwards. Okay. And a painter want to paint the wall of a building. It stands. Is about 800 Newton. Okay. He stands 1 meter away from the left. Okay. It's 1 meter away from the left corner. Okay. And it's 800 Newton. The plank, the platform as the platform as is 4 meter, is 400 Newton of weight. Okay. It's a uniform platform. What is meant by uniform? Uniform means the weight is acting at the geometrical center. Okay, that's our uniform. That means 4 meter means you can take the weight is acting, the 400 Newton, the weight is acting at the center of the plank. If they put non-uniform means, what's the problem you're going to face? The center of gravity is not at the center. It's somewhere maybe the more massive region lah. So if they put non-uniform, please don't put the weight at the center of gravity, center of the object. No, non-uniform means the weight is not acting at the center. It's somewhere, we don't know, we have to find out. Okay, so a uniform is a ticket to show that the weight is acting at the center. Okay, so it's a uniform platform, it's 400 Newton. Now the question is, the cable has tension T1 and T2. Okay, this is the first cable, T1 and T2. Calculate for me, find for me, okay, T1 and T2. Okay, 2 minutes for you. Come on, give a try. Use your moment and your net force knowledge. Find the T1 and T2. Calculate the moment at a point you think is should be easier. Okay, you have two unknown. From net force you can get one force. From moment you can get a lot of equations. The platform is 400 Newton down. The painter is 800 Newton weight. It's 1 meter away from the left corner. What is the tension T1 and T2? You can WhatsApp me the answer. Okay, so send me the answer. T1 is what? T2 is what? So two unknown, you need two equations, of course. The easiest is the net force. Net force can give you one equation. And moment can give you another one. Okay, so I got the answer. So all of you got this. So your friend said T1 is 800 Newton. Oh yeah, two of you said T1 is 800 Newton. And T2 is 400 Newton. Okay, so all of you got this answer?
Yes.
Okay, so from net force, force up equals to force down. So T1 plus T2 equals to force down. Force down is how much? 1200 Newton. This is the first easiest equation we can make by using net force. Okay. Second equation, I think I don't want T1 to appear. I don't want T1 to appear. So I take moment about this point pivot here. I take moment about moment, okay. Moment about okay, I mark here point A, mark here point A. Moment about point A. Okay. First, in exam, you have to write this wording. You must tell you are taking moment about which point. This could carry 1 mark. Okay. So don't straight write equation. You just tell you are taking moment about each point. So if you're taking moment about A, then what are the moments happen? This give a down moment, clockwise moment. The 400 Newton also give clockwise moment. T2 give a anti-clockwise moment. So how's the equation going to be? The person 800 Newton, 800 times perpendicular distance is 1, should be plus 400 Newton, 400 Newton times perpendicular distance from the point A is how much? 2. Should be equal to the moment caused by the T2. T2 times the perpendicular distance, which is 4. Yes. So these are two equations. So the first one, second one. I think second one, you straight away can find the T2 already. T2 already. So T2 you got 1064, so 400. So you get 400 and these 200. Okay, good. So this is how the working should be. Okay. So those who got answer T1 800, T2 400, good. So keep it up. So this is how you have to analyze the system. Okay. So any questions so far?
No.
Okay. So I'm going to skip this part because it's all about moment. Okay, it's all about moment. We straight go to the next part. Okay, the next part, what we're going to do is we're going to talk about density, pressure, these two. Okay, this is something you learned before. Just recall back. Okay, okay. First, density. What is density?
Mass per volume.
So you know that it's mass per unit volume, and mass per unit volume. So unit is kg per meter cube, and the concept of density is used to find how close, how packed the matters are contained in a unit volume. Okay. So yeah, different substance has a different density. Water is like 1000 kg per meter cube. Air is like 1 kg per meter cube. Okay. Which substance in the world has the greatest density?
Black hole.
Oh yeah, good. Black hole. Denser than black hole.
Singularity.
Singularity. Yeah, that's the nucleus. Yeah. So yeah, black hole made of lots of subatomic particles, but still the nucleus is found to be the most high dense. What do you call object? Microscopic level. 10 to the power of 80. Okay, the solid density is constant throughout, and fluid can be compressed. Density is constant. Cannot be compressed. Density is still constant for fluid. Actually, especially liquid. So if can be compressed, density change. Whenever there is a change in temperature and pressure, fluid density may change, right? High pressure means density can become more greater, right? High pressurized. High temperature, density can drop. The temperature increases separation between the molecules. So volume increases, so density drops. Similar to pressure increase, volume of the fluid decreases, density can increase. Okay. So pressure and temperature can play a role in a density of a material. Okay. Okay. The density concept you already know earlier, but Cambridge have a different way of asking the question. Okay, look at this question. In a mixture of 100 gram, two liquid A and B are mixed with a ratio of 1 and 3 of their masses. The density of liquid A is 1.25. The density of liquid B is 0.6. Determine the density of the mixture. Okay. 1 minute for you. Get me the answer. In a mix with 1 to 3 ratio. In a mixture of 100 gram, two liquids are mixed in a ratio of 1 to 3 of their masses. Determine the density of the mixture. Anyone, please send me the answer. Okay, so 1:3 ratio mixture. That means 250 out of 100 gram. I think 25 gram goes by what contributed by A, and 775 grams should be contributed by B. 1:3 ratio. So determine the density of the mixture. Anyone got the answer? Send to me. So liquid A and liquid B. Liquid A, this is the first thing, the hint. I give you the hint. Because it's 1:3 ratio, liquid A must be 25 gram composition in that 100 gram. Liquid B must be 75 gram. Okay. You want to find new density. New density means, how do you find density? The total mass divided by total volume. Total mass we know is 100 gram. We need to find total volume. How to find total volume? You need to find volume A of 25 gram how much. You need to find volume B of 75 gram how much. That two volume added is the new volume of the mixture. So what is the volume of 25 gram of A? So 20 centimeter cube, 125 centimeter cube. Okay, 20 centimeter cube, 125 centimeter cube. Correct. How do you get 20? So density, mass, or volume. Mass is 25 gram. Density of the A is 1.25, so you can get 20 centimeter cube. So therefore, A and B mixture, the total mass is 100 gram, total volume is 145 centimeter cube. Therefore, the average density, new density is 0.69 gram per centimeter cube. Okay, so this is how they ask in Cambridge. They mix two liquid, they ask new density. Okay, so how to find the new density? You need to get a new total mass, you need to get a new total volume. Okay, then you divide the total mass and total volume, you get the new density value. Okay. Okay, get me the answer for 21. 1 minute for you, come on. Similar as the earlier question, the concept. A mass of a liquid density rho is thoroughly mixed with equal mass of another liquid of density of 2 rho. No change of total volume occurs. What is the density of the liquid mixture? Okay, so give me the answer. Okay, what's up? Okay. One body is rho, another one is 2 rho. Okay. Okay. Their mass is same. So if this is M, this also we put M, the mass is same. So these two are mixed. So you got a new substance. What is this new density B? That's the question. So to find new density, you need to know this total mass here. What is the total mass? What is the total mass? Total mass, how much? So of course, here M, here M. So the total mass will be 2M. Huh? Okay. Now you need to get total volume. What is the total volume? Okay. Total volume, they never give any symbol. We create one. Here, density rho, mass is M, volume, let's say I put V. This should be how many V? This is 2 rho. M over V is rho. Rho is what? I create this. M over V is rho. Mass M as a volume of B, density is rho. Now the second substance, mass is M. How much is the volume should be so that it become 2 rho? Which is denser? This second one is denser one. Denser means volume should be how many V?
Less.
Should be less. How much? To get 2 rho, 2 times of the rho. Should be half V. Right. M over V is rho. M over half V will be 2 rho. Okay. So the volume here is V. The volume here is V over 2. Both add up. Total volume how much? V plus V over 2 is 3V over 2. Right? 3V over 2. So what is the new density? So new density is total mass over total volume. So total mass is how much? 2M over total volume is how much? 3 over 2V. So finally, what do you get? You get 4 over 3. 4 over 3. M over V is actually the rho. M over V is actually the rho. So the answer is 4 over 3 rho. So A is the answer. Okay. So you got an idea? So you need to create the volume. This V, this is half V. That's the trap here. We take this as V. So this should be half V because 2 times of the density, volume must be 2 times smaller. Then when they mix, the volume simply added, new volume, 3V over 2. Mass also simply added is 2M. So 2M over 3V, 3 over 2V get you the new density. Okay. So yeah, liquid A, Mg, this is another way lah. Rho, M rho, 2 rho, get 4, 3 rho G. Another way. Okay. Question 22. It's a fact to remember. It's a fact to remember. You see, for a solid, liquid, gas, okay, solid, liquid, gas, the molecular spacing for solid, liquid, gas will be 1, 1, 10 ratio. Fact to remember. You have to remember this fact. Solid to liquid, the atom, right? The atom, the spacing for solid and for a liquid, the spacing they say unchanged. It's still the same. But when it comes to gas, they say the spacing between the atom increases by 10 times. Okay, in average. So molecular spacing for solid, liquid, gas should be 1, 1, 10. It's a fact to remember. Okay. Now when it comes to density, how's the ratio going to be? Density, this is rho means this will be rho. 1 1 lah. The ratio is 1 1. Okay. Okay. What is the density of gas will be? It's 1 divided by how much of volume rises? Volume spacing rise by 10 times, you know. Atom is 3D, 3 dimension. So the 10 times spacing happens in 1 dimension 10. The spacing inside also increase by 10. The atom outside also increase the spacing by 10. So the volume occupied by one atom increased by how many times? In 3D view, to the right 10, inside 10, up 10, 3 dimensions. So the volume rises by how many times? Rises by 10 times 10 times 10. So it's 1000. The volume increased by 1000 times, you know. So the new density will be for the gas is 1 over 1000. So the ratio should be 1 1 1 over 1000. This is the ratio of density. But to make a round figure, all you multiply by how much? All you multiply by 1000. What do you get? You get 1000 1000 1. You get 1000 1000 1. So the answer should be A. These two are facts to remember. So solid liquid gas, the ratio is what? 1 1 10. Okay, the spacing ratio. The density will be 1000 1000 1. Density of solid and liquid is about the same in A levels. A levels we treat solid and liquid as the same density. Gas density going to drop by 1000 times because spacing rise by 10 times for A levels. Okay, any questions from here? Can okay. Okay, so spacing is spacing between the atom is 10 to the power negative 10 lah. Spacing between the gas is 10 to the power negative 9, 10 times lah. Atom and molecule assumed to be sphere. Private in all 3 directions covering the space of shape of a cube. Okay, the volume used by one atom we assume is in a cube shape. Okay, let's say you have a volume up and inside got volume. So the volume occupied by the one atom we assume is like a cube shape. Okay, it's a cube shape. This is the spacing of the atom. Okay. If this increase by 10 times means inside will increase by 10 times. Up also increase by 10 times for the case of gas. So the volume occupied by the atom we assume is like in a cube. Therefore, volume in atom's molecule can be calculated by d cube. Yeah, the volume can be d cube. Let's say spacing is 10 times greater, so we put 10 times, 10 times, 10 1. We are treated as a cube, the volume. Okay, class. So work out for me this question, get me the answer. Still density. What is the answer for part 1? Calculate for me. Density of liquid water is 1 gram per centimeter cube. Density of water at atmospheric pressure is 1 over 1600 gram per centimeter cube. Determine the ratio of volume of water vapor over volume of equal mass of liquid water. How much is the ratio? Work out for me. Density is mass over volume. Yeah. So volume is what? Volume is mass over density. Okay, use this for both up and down. Okay. Ratio. What is volume of water vapor? Mass times mass over density. Density of water. Determine the ratio. So mass for both of them we assume same lah, because determine the ratio. So mass up here m over density of the water is how much? Is 1 gram. You put 1 gram divided by liquid. Oh, sorry. Let me see. On top is vapor. Vapor is 1 over 1600 lah. Okay. Down how much? Still the mass over liquid density is what? 1. So what do you get? So up is actually become 1600 m, 1600 m. Down is just m. So you got 1600. So answer should be 1600. We must use the same mass because we are comparing with the same mass. Okay. Okay, so that's the answer.
Question. So
Yeah.
we write in ratios, so that means that it's 1601 ratio of 1.
Yeah. Ratio of 1, correct. 1600 to 1.
Oh yeah.
Okay. Okay, now next 2, how do you find out? What is the mean separation of molecule of water to the mean separation of molecule of liquid water? What is the mean separation of vapor or mean separation of water? How mean separation and volume related? Atom separation, let's say, is D. Is D. How D linked to volume? Volume occupied by one atom. D cube is the volume. Please remember, because we treat the volume as a cube. So the spacing cube is your volume. So what is the mean separation between the volume of water? The spacing is spacing in terms of volume. How should be? Spacing is cube root, right? Cube root of the volume, right? Cube root of the volume is the spacing, correct? So here we are looking for D of the vapor over D of the water is equals to cube root of what? Volume of the vapor, cube root over cube root of volume of the water, correct? Cube root. Okay, how that spacing related to volume. So this is actually, we can combine, right? Combine cube root of what? Volume of vapor over the volume of water. So volume of vapor over volume of water, we already know how much. That's the first answer, right? The first answer is what? Volume of vapor over volume of water is 1600. So the value inside here is 1600. So what's the answer then? So it's cube root of 1600, your ratio of the spacing. This is your ratio of the spacing. 1600 cube. Okay. So the important thing you learn here is what? How the separation related to volume. Separation cube is the volume of the atom. Okay, volume occupied by the atom. Okay, so yeah, so this is the first answers, and this is the second answer. So D cube. So we get 11.7.
See.
Okay, the volume, the ratio of the volume is the ratio of the volume you get like this. So volume is actually spacing cube, spacing cube. So cube root 1600, you get the ratio of the spacing. Okay. So this is a different way of how density question will be asked in A levels. Okay, they'll mix two different liquids. We ask for the overall density. Okay. Okay, so that's about density. Okay. Okay, one question from the past year. Go back to the past year. Okay, 21. This is sorry, let me check. This is your page 12, page 12, question 21. Two solid substance P and Q have atoms of MP, MQ respectively. They have NP and NQ atoms per unit volume. It is found by experiment that density of P is greater than density of Q. Which of the following reduction from this experiment must be correct? See, the concept is density, but see the way they write the equation, they're trying to confuse you. Please read carefully. The two substance as every atom of P as a mass of MP. MP is mass of one atom. MQ is mass of one atom of Q. So P is density P is found to be greater than Q. So NP and NQ atoms per unit volume. Yeah. NP is the number of atoms per unit volume of P. So which should be the answer? Can you send me the answer? So all of you go for C. This is C. How to find this? Okay, all of you got C. C makes sense. So you have to start with density of P greater than density of Q. That's what working. Let me put the whiteboard. Okay, let me pull this up. That you can see both together. Okay, so see here. So density of what? Density of P is greater than density of Q. Density of P is, we know, is mass over the volume of P. Mass and the volume of P. So mass of P and the volume of P. Mass of Q, volume of Q is greater. Okay, now they said the P got NP of number of atom per unit volume. And each atom got mass M. So how do you write that? Number of atom times mass of one atom, MP, divided by volume is the density, right? N is the number of atom. Number of atom is the mass of the one atom. It makes the total mass divided by the volume. Okay. But number of atom divided by volume, they say it is what? Number of atom divided by per unit volume. Number of atom divided by per unit volume is NP. NP, MP. So we got NP, NP. So NP, MP must be greater than NQ, MQ. So this is the answer. Okay. So it should be C. C should be the answer. So here the trap is the mass. The mass is number of atom times mass of one atom. But number of atom divided by volume is NP. That's what they say here. Okay. NP is atom per unit volume. So that is N over V value. Okay. So therefore, those who got C, good. This answer should be C. Okay. So any questions so far? This is our today's lesson. I don't want to drag further. So we learn about continuation of movement, And after continuation moment, we talk about density. Okay, density. I need another one class to finish. The next part is pressure. Okay, so I think another one class we spend for this topic lah. Finish it off the pressure, then we're done with force. Okay, then we'll be continuing with the topic 6. Any questions so far? Okay, no questions. Okay, class. So see you then tomorrow. Tomorrow, 10 o'clock, we'll be continuing with pressure. Okay, try to revise some pressure. Then we will done with that topic. Okay, so if you don't have question, then we can stop here. Okay, so no questions. Okay, see you then. Bye.